So this is my quick review series, and in this video we're going to just review everything about a function. So functions actually are a specific term that are related to a larger term called relations. So you can't talk about what a function is without talking about a relation. So a relation is a way to describe the relationship between any two elements. So any way that you want to do it. And so what a function is it's a specific type of relation where each input has exactly one output. So a relation is any way you want to describe a relationship, and a function is having each input has one output. So it's a specific type. Now, lots of things you have seen are functions. So the thing about functions is like when you learn them, like a lot of times it's like, okay, I'm not really learning anything new. But like here, let me show you a bunch of things that are functions. So all of these would all be functions. So this x squared plus 3x minus 2, square root of x cubed, e to the x, 1 over x, sine x. Now, whether or not you know all of these graphs is totally, that doesn't matter. If you don't know what sine of x is, that's not a problem. But the point is, like, these, like, lots and lots of things are functions. So probably most of the things that you study end up being functions. And so it's just kind of noting what makes this type of relationship special, I guess. Now, functions, one of the reasons that we like them is that they have a really convenient notation that looks like this. So it's this f on the outside, parentheses, and x. So you do want to pronounce this in the correct way. The way that we say this is f of x. And you don't have to use f. You could use other letters, so g of x, a of t, h of x. As long as you know that this represents a function, then you can use whatever letters you want for the notation. So the reason that we like function notation is because it makes it really obvious as to what we want to do with a particular expression. So for instance, I have f of x here and g of x here. And so if I asked you to evaluate f of negative 2, so first of all, you know exactly which of these two equations I'm referring to. And then also you know what I want you to do with this. So when you put something in here, that means replace all the x's with whatever I put in here. So for instance, if I want to do f of negative 2, I'm just going to plug in negative 2 into this function. And so there we go. And then I can go ahead and just evaluate this, right? So this becomes 4 plus 6 plus 1, so that will just equal 11. Versus for g of 5, now again, you know exactly what I want you to do and which equation I want you to do it with. So I'm asking you to plug 5 into this equation. So this will be 4 times 5 plus 5, so that's 20 plus 5, so that's going to be 25. Now, the thing that makes this very powerful, actually, depending on what level of mathematics you're going into, we do kind of weirder looking things with functions. So this says g of a minus 4, but the idea is still the same. So there are reasons why we might want to plug in strange things into this, and I'm not going to go through that in this video. I'm just going to say there are reasons, and if you want to find out those reasons, go take more math. But so I've got a minus 4. So where I have this x, I'm going to replace it with a minus 4. So this is going to become 4. Now where I had an x, I'm going to replace it with a minus 4 plus 5. Now, all you're being asked to do is evaluate. So from here, it's not like we're trying to solve for a or anything. So I just have to simplify this as much as possible, which the way that I would simplify this then is I would go ahead and distribute that 4. And so then this is going to give me 4a, 4a minus 11? Yeah, and that's it. We're not being asked to solve. We're just being asked to evaluate. And so we get the same thing here, actually, f of x plus h. And this is actually f of x plus h. This is something that you compute when you get into, say, like calculus. And so a lot of times in like a pre-calculus class, you are asked to evaluate this. So I would say, actually, I would suggest that you pause here and you try this on your own just to make sure you've got it. Okay, I'm going to go ahead and do it. So this is going to be x plus h squared minus 3 times x plus h plus 1. Okay, so notice, right, I have x plus h. So everywhere there was an x, boom, boom, I replaced it with x plus h, boom, boom. And from here, it's kind of that same idea, right? So it's just, what else do I have to do? Well, with the x plus h, so we have to be careful with this squaring thing, right? Because what I have to do is I have to take x plus h times x plus h. So I have to FOIL that out, right? But for the rest of this, I can go ahead and distribute the 3. So this is minus 3x minus 3h plus 1. And then I can go ahead and distribute all this. So this is going to be x squared plus 2xh plus h squared minus 3x minus 3h plus 1. So this would be everything evaluated. And this is something, like I said, you have to be able to do this for calculus. So depending on what reason you're using this video for, this is actually a pretty important skill to have. Okay, so let's go back to talking about this relationship now with functions. So we talked about input and output. So these two ideas actually have names. So a domain refers to the input values of a relation. So this would be an x value. And a domain is for a relation. It's not just for a function. So everything has a domain, but we'll talk about what makes something a function in a second. And then for a range, these are the output values of a relation. So we could think of these as the y values. So when we're talking about functions, what we're really referring to here is a special set of relationships. So you can think of domain and range like I've pictured here, where, okay, so I want you to notice what's going on in this picture. So here I have my domain. These are my inputs. And you can see that I have mapped them in a certain way to my range, to my outputs. And so in this case, notice each input goes to exactly one output. And so if you remember, that is what the function is, right? So it's a special type of relation where exactly each input has exactly one output. So when we look at this picture, that's what's happening here. This is exactly what I mean. So this would be a function. And if I go here, right, we have the same thing actually. So here's my things in the domain and here's my things in the range. So I can see each input is being mapped to only one thing in the output. Now, what you'll notice is that these two inputs are being matched to the same thing in the range. That's totally fine. This is not a problem. This is still a function. So the third picture, though, is not a function, right? Because now I have one of my inputs being mapped to two different things in the range. So that's a problem. And so this is not a function. And so understanding domain and range gets really important depending on what level of math that you're going into. And so a lot of times you are asked to describe what the domain and range are, partially so that you can just think through whether something is a function. Now, one really easy way to determine if something is a function is with the vertical line test. This is super simple. So this is as stated. So if any vertical line passes through a graph more than once, then the graph is not a function. So I'll just show you this. It's easiest to show you this. So I've got these two graphs here and I took them off Desmos.com. Okay, so what I'm going to do is I'm just going to draw some vertical lines. So those are lines going this way. So you'll notice that in this picture, no matter how many vertical lines I draw, they will never intersect the function more than once, right? Versus this other one, here's a vertical line and it intersects this twice. So this one would be a function, while this one would be not a function. It is a relation, but it is not a function. So the vertical line test makes it really easy to determine whether or not you have a function. So if I look at these two examples here, so for C, so we can see C right away, right? Not a function, not a function. Versus this other one, so every vertical line that I draw only intersects once, so this would be a function. Okay, now speaking of graphs, as far as how graphs of functions work, these are no different than any other graphs. So I've already reviewed in another review series how to graph lines. So the thing to know about functions is that f of x is interchangeable with the letter y. So I could actually rewrite this as y equals 4x minus 1. So as long as you've got a function written like this, you can always replace this with y. And a lot of times when we graph things in terms of having y here instead of f of x. And so once you see this, right, you can see that this is in slope-intercept form. If you're not familiar with that, I do have a video on that, so I recommend that you go check that out because I'm just going to assume that you know that here. But so I have y equals 4x minus 1. So my y-intercept in this case would be -1, and my slope would be 4. So I'm going to count up 1, 2, 3, 4, and over 1. And then I just graph it as usual. So graphs of functions, they work like just graphs in general. So that just the key is to know that f of x and y are interchangeable. Now, the next thing that I want to talk about in this video, which will be kind of the last thing that I talk about, is function operations. So this is a little bit different from just evaluating functions. So we have shorthand to show when we want to do certain things with functions. So if I want to add two functions f and g, so I want to take f of x plus g of x, I can use this shorthand here. So this is just shorthand for doing certain operations with functions. So if I wanted to take f of x minus g of x, I could write this as f minus g. If I wanted to take f of x times g of x, I could write it like this. And if I wanted to take f of x over g of x, I could write it like this. So this is really like a shorthand to show that you want to add, subtract, multiply, or divide with functions. So sometimes you'll get problems that look like this. And so it's just then knowing what this notation means. That's really what the key to this is. So I have these functions f, g, and h. And I'm being asked to evaluate what is f plus g of x. Well, it's almost like silly in some ways, because then you like the most helpful thing to do is just to rewrite what does that mean, f plus g of x. It means f of x plus g of x. But then you can refer to those functions, right? So f of x is 5x minus 2. So I can take 5x minus 2, and then I can add that to g of x. So g of x is x minus 2. So I can just go ahead and, oops, sorry, I had a problem with my mouse there. Okay, so let's see. X minus 2. Okay, so I can add those up together. Now, I have a tendency to put parentheses around these just so that I can differentiate which function is which, but do I really need the parentheses? I don't. I just do it because, well, you know, I do have like some higher degrees in this, and so sometimes I just need it to look really nice. But no, we technically don't need the parentheses, okay? All right, so anyways, so this is going to equal, so 5x plus x is 6x, and then negative 2 minus 2 will be negative 4. So the answer in this case would be just, 6x minus 4, and that would be it. Okay, so what about if I want to take f times h of x? So I would actually recommend that maybe you pause the video here and try that on your own, just to make sure that you've got this, and then hit play when you're ready. So this means that I want to take f of x times h of x. So I need to write that out, right? So if I write that out, that's going to be 5x minus 2 times x squared minus 4. And so in this case now, I just need to multiply all of this stuff together. And again, I'm assuming in this video that you already know how to multiply out polynomials. If you are looking for a review of that, I also have a video on that. So be sure to check that out if that is something that you need. But I'm going to go ahead and multiply these together. So this is going to be 5x cubed minus 20x minus 2x squared plus 8. And that is all that I can do for that one. So I've evaluated that as far as possible. Now, I want to contrast that though to what if I put a number in for these. And so now this gets a little interesting. You have a couple different ways on how you can evaluate this. But I guess the way that I think about this is I think of this as f of 3 plus g of 3, right? That's all it's really asking us to do. Now, alternatively, if you knew what f plus g of 3 was, you could also just use that form. And you will remember, right, so we were just doing this, right? So we just did this here, and we found that we got 6x minus 4. So if you know what that comes out to, you can also just use that. So what I could do alternatively is instead of having 6x minus 4, I could write this as 6 times 3 minus 4 and just shorthand this. So this becomes 18 minus 4, so this will equal 14. So I could do that, but what if I don't know what this works out to? So say I have f minus g of negative 2. So we did not work this one out, right? We haven't done f minus g. So in that case, you can also just work this out in pieces like I was suggesting before. So I can go ahead and just evaluate what is f of negative 2. F of negative 2, so let's see, I'll plug that in. So this is going to be negative 10 minus 2, so this will equal negative 12. And g of negative 2, this will be negative 2 minus 2, so this is negative 4. So I have these two answers here. So if I want to then evaluate what is f minus g of negative 2? What I can do is I can take negative 12 minus negative 4. So that really becomes negative 12 plus 4. So that will equal negative 8. So there are different ways on how you can evaluate these, right? And it's kind of just up to you. So you can evaluate it in pieces like I did here, or if you just know what the function should work out to be, you can just plug it in. So it's tomato, tomato. It's a little bit of preference. So I have one more here just for funsies, h over g of x, just throwing in like another thing that could happen. So with division, so one thing that you can watch out for, so if I actually plug these in, so I need to take h of x over g of x. So if I plug that in, that's going to be x squared minus 4 over x minus 2. So the last point that I want to make up with these function operations is that really anything can happen. So you just kind of want to think about what do you know. So in this case, I have x squared minus 4 over x minus 2. So what I notice is that x squared minus 4 can be written as x minus 2, x plus 2. So I can actually factor that. And in factoring that, that allows me to cancel out the x minus 2's. And so then I'm just left with x plus 2. So anything can happen when you're doing these function operations. So you just need to kind of think about like all of the math that you know. Now, the last type of function operation that I want to talk about in this video is the composition of functions. So it always looks like this. A lot of times people think this is the word fog. It is not the word fog. So this is an f. This is like a tiny little circle and then a g. So it is not like a funny way to write fog. It is f circle g of x. So this is the composition of functions. So what does this actually mean? Well, when you see this, what this means is this is actually asking us to do f of g of x. So we're putting g into the f function. I think it's probably easiest just to demonstrate this with an example. So I'm going to go back to the same set of stuff that we had before. So I want to calculate f of g of x in this case. So like I said, so the composition is, it stands for this, f of g of x. So in general, what you want to do is you want to start from the inside and work your way out. So what I'm going to start with is I'm going to replace that g of x with what g of x actually is. So this is going to become f of no longer g of x, but f of x minus 2. And now you can also see why it was important for us to take that time to evaluate functions with like weird stuff kind of input into it. Because now what I have to do is now I have to evaluate f of x minus 2. And of course, if I look up here, so here's my x minus 2, I'm going to basically replace this x with x minus 2. So let me go ahead and do that. So my f is 5x minus 2, but now where there's an x, I'm going to replace this with 5 times x minus 2 minus 2. So notice I maintained this whole function, right? But where there was an x, where this x was, I replaced it with x minus 2. And then I've still got the other minus 2 because that was from the function, right? So now it's just what else can I do with this? And I can distribute the 5. So if I distribute the 5, this becomes 5x minus 10 minus 2. And that'll equal 5x minus 12. So that would be the answer in that case. Okay, so let's do another one of these together. And then maybe I'll have you do a couple on your own. We're almost done with this, by the way. So, okay, so h of f of x, that's the way I want to write this. So it's always whatever comes outside and then inside. Okay, so let's go ahead and evaluate this. So remember, we work from the inside out. So this is going to be h of, so f of x is 5x minus 2. And now I want to plug this into my x here. So this is going to be 5x minus 2 squared minus 4, right? So now where I had x squared, it is now 5x minus 2 squared. And in this instance, right, so it just depends on like the way the problem is written in terms of what you need to do next. So next, I need to multiply all this stuff together. So this is going to be 5x minus 2, 5x minus 2, minus 4. And now I can go ahead and multiply this out. So this is going to be 25x squared minus 10x plus 4 minus 4. So this will equal 25x squared minus 20x because the 4's will drop out. And so that'll be it for that one. So it just kind of depends on the type of problem that you've got. Now, one thing I want to state here, so let's just review real quick. So we did f of g of x, and I want to note that we got 5x minus 12. So now I want to go in the other order. So does it matter which order that you go in? So I've got g of f of x. Well, I think that you should answer this personally. So I think you should pause the video here, give this a try. Remember, math is not a spectator sport. You will learn more from this if you try it. Pause here, give it a try, see if you can answer the question. Okay, so what I need to do is g of f of x. So I start from the inside. So let's see, this is going to be g of 5x minus 2. So if I plug that in, this is going to become 5x minus 2 minus 2. And so what does this equal? This will equal 5x minus 4. So definitely not equal to, right, before we had 5x minus 12, and now I have 5x minus 4. So the order of your composition totally matters. You do want to be careful with that. Now, the last thing that I want to talk about is what do we do if we have to take the composition of a number? And it's very similar to what we were just doing with operations with numbers. So what we can do here is we can do g of h of 3. Okay, so this is a slight difference. So what I need to know first is what is h of 3? Well, I can just plug in the 3. So I can take 3 squared minus 4, so that's going to be 9 minus 4, so that will equal 5. Okay, so h of 3 equals 5, so I'm going to replace that in this case. So now I'm going to have, what is g of 5? So in some ways, I actually think this is a little bit easier if you have a number. So now I just have to evaluate what is g of 5, and that's going to be 5 minus 2, so that will equal 3, and that would be the final answer in that case. So if we have numbers, like I said, I think it's a little easier to do. So that actually brings us to the end of the video. So I do try to keep these videos on the shorter side, but if you feel like you need to do more examples because you don't quite get it, don't worry, I've got you. So all of my review videos come with more practice problems. So this means that I have a PDF of problems with an answer key, but I also have worked out video solutions. So you can either do practice or you can watch more examples, whatever you need. So it's all at divideandconquermath.com. I'll also drop a link in the description to the example video or to the practice problem video. But you can go to divideandconquermath.com and check out the review section if you want to find it that way. As a reminder, you can't just watch a ton of YouTube videos to learn math. You do really need to practice it to master the skills. So I would caution you on watching tons of examples. And I would say maybe consider trying to just do the practice problems just to master the topic, but you know, you do you. And by the way, my review series has many other topics in it, so all of my topics work the same. I have a refresher video, practice problems, and an answer key. So if you are interested in checking out more review, go to divideandconquermath.com. Everything is free. Just go to the review section and you'll find everything that you need. But I am going to leave this video at that, and I hope to talk to you guys in another video. Bye!